in this video I'm going to explain you the topic of CNF and DNF, which means conjunction normal form and disjunction normal form. And in this part we will see the definitions and the examples for this. Okay, now we will first start up with the definition, simple definitions of elementary product and elementary sum. Okay, so product of variables and the negation, product of variables and the negation elementary product, and sum of the variables is elementary sum. Okay, in this example P and Q are two variables and they are connected by the product conjunction part. Okay, so this is the example of elementary product. Is the same way like negation P is a variable and Q is a variable. So here this conjunction sign is connected this both, and it is in normal terms it is called product. Okay, and by sum we mean disjunction. Okay, by sum we mean disjunction and by product we mean conjunction. Okay, I hope you are understanding this thing. After this the definition for this is sum of the variables, like these are the variables and their sums. Okay, and then negations like you can see here and here. Okay, I further explain you more thing, then the topic will be clear for you. And here we are seeing normal forms. In this we know that there are two types in normal form. There are two types, DNF and CNF. Okay, and DNF, as we know by name, disjunction normal form. Disjunction normal form. What is the definition? Sum of elementary product. The sum. This is the variable, and this is the sum. In this we can see that the variables are connected by AND. Here also variables are connected by AND. And in this product of elementary sum. What is the difference? Just a minute, there is a mistake, a minor mistake. And this here the sign will be of this. Okay, because the sum of, here we know that the sum of elementary products. Okay, products का सम करेंगे यहाँ पे, तो ये जो दो प्रोडक्ट है उसका आ गया सम. सम मैंने बताया था आपको कि डिसजंक्शन का साइन होता है वो सम होता है. ठीक है, यहाँ पे क्या है, प्रोडक्ट ऑफ एलिमेंट्री सम. सो यहाँ पे जो है एक ये वाला और एक ये वाला किससे कनेक्टेड है, प्रोडक्ट से कनेक्टेड है, कंजंक्शन से कनेक्टेड है. सो ये दो के अंदर सम है और वो दोनों कनेक्टेड है किससे, प्रोडक्ट से, कंजंक्शन से, सॉरी. ओके, तो इसका एग्जांपल ये, दूसरा एग्जांपल ये है पी क्यू एंड आर. तो क्यू एंड आर जो है वो कनेक्टेड किससे, एंड से, और इसमें क्यू और आर जो कनेक्टेड है किससे, वो एंड से. ओके, आई होप यू अंडरस्टैंड दिस थिंग. उसके बाद इसमें देखो तीन मेथड्स होती है कि हाउ टू फाइंड द CNF एंड DNF in a proper way. Okay, so first what we will do, first we have to remove the implication sign and conditional sign and biconditional sign. Okay, and this, so in the method we will remove this conditional sign and biconditional sign. So I'll explain you that how to remove this both the signs and what to use in behalf of that, what logical equivalence we can use by removing these two things. Okay, and the second step is eliminate negation before sum and product. We can eliminate this negation sign by De Morgan's law, as I taught you in the last lecture. And in De Morgan's law we can multiply by negation, and we can also remove the negation by the help of De Morgan's law. Okay, and in the third part we will apply the distributive law. In the distributive law we know that as in the last lecture I told you that in distributive law what happens when we have two things Q or R. So we distribute this thing to both the parties. Okay, both the variables. So now I'll explain you that how to remove this and how to apply this. Just a second. Okay, so note this point, as I have told you, this is the important thing, this and this. Okay, whenever we want to remove the conditional sign, and it is between two variables, P and Q, so we can remove it by negation or. Okay, whenever there is like P and Q, so what we can do, negation P or Q. we can write this both are same. Okay, so when it is told in the question that remove this sign, then on behalf of that logical equivalence we can use this. Okay, and then the second thing, when we have biconditional sign in variable p and q, there is a sign of biconditional, and when we want to remove this biconditional sign, there are two methods. Like first we can use this part also, that p tends to q and q tends to p. Okay, so first thing we can also do this by this thing or by this thing. Okay, as per the question's requirement, like what is asked in that question. Okay, so here we have first one, p by conditional q, so we can write that p conditional q and q conditional p. Okay, we can also write this. And the second one we can also write like, if it is given like this, p by conditional q, we can also write it as p and q or negation p and negation q. Okay, I'll help you know that where I applied this one and this one, then you will know how to apply this both at other places. I'm again explaining this De Morgan's law. In De Morgan's law, I told you that whenever there is a negation sign in this whole, we can give this negation sign to both the variables, negation p and the question in, we will also change this sign, negation p, negation q. We gave this negation sign to both this thing, but the sign which is in between both the variables is conjunction, so we will replace it by disjunction. Okay, the same thing here, this is the sign of disconjunction in between this, so we will make it conjunction. Okay, both are same, we just have to change this and we will replace it by this and we will replace it by this. Okay, as I told you what is distributive law, and I even explained you this thing in a last lecture. I'll again recap this thing. So when there is like p or in brackets q and r, so we have to give this p to both the parties inside the brackets. Okay, so first we will give it this to q and then to r. Here we have seen this p or q, p or r, but the sign which is between this we will put this. Okay, so we just have to remember this, जो ब्रैकेट के अंदर है वो हम ब्रैकेट के बाहर रखेंगे, समझे, जो ब्रैकेट के अंदर है उसको बाहर ले लेंगे और जो बाहर है उसको अंदर ले लेंगे, समझे, जैसे कि ये बाहर है तो उसको हमने अंदर ले लिया ये साइन, और जो ब्रैकेट के अंदर वाला साइन था उसको हमने बाहर ले लिया, समझे, ये नॉर्मल चीज़ है, डिस्ट्रीब्यूटिव लॉ में हर जगह पे यही अप्लाई होगा. ओके, वैसे ही सेम यहाँ पे ये और के लिए था, ये एंड के लिए. होप यू अंडरस्टैंड दिस थिंग. नाउ विल जंप ऑन द एग्जांपल्स ऑफ DNF. लेट्स सी. सो if in the question it is given like p and in brackets it is given p or p conditional q, so how we can solve this? As I told you, we can replace conditional sign here. I told you that we can replace this conditional sign by negation p or q, so we applied this only. Here it is as it is, and in the here we have used negation p or q. Okay, after this what I have done, p and negation p and this p and q. So first we have applied this formula, and now we will apply distributive law, and we will give this p to both the variables. Okay, so first I have given to this p and negation p and p and q, and the sign which is inside will come outside as I told you, and which is the outside will be distributing, it is inside. Okay, and now we will see the second example. Hope you will clear this topic very well. I'll also give you the third example which is more tough, and by that you will be clear this topic in a very nice way. Okay, so this is the second example, and this the same thing is like p conditional q and negation q, so we will break this into negation p or q, and this will be as it is, this thing is as it is. Okay, and now we will do, we will apply De Morgan's law in this. We applied the De Morgan's law in this, and what happened, sorry, we didn't apply the De Morgan's law. Okay, I'm really sorry, we didn't apply the De Morgan's law. We apply the distributive law in both this thing. So first we gave negation P and negation Q here, and the second one we gave Q and negation Q, and here the sign which is inside we brought it outside, which is disjunction, and the conjunction which is outside we made it inside. Okay, so why do we provide this sign here? What it is given in the question, disjunction normal form, so we need the disjunction in the final answer in between all the formulas. Okay, so here we can see this, there are two parties and in between the sign of disjunction. Here also same thing, there are two parties and in the middle there is a sign of what? Disjunction. Okay, so this proves that the answer is right, that you are at the right position, and this is the answer for the DNF. Okay, you have to do this step after this, and it is compulsory for you, because if you will be stopping here then the answer will be wrong. Okay, because if you are stopping here then this answer will be for CNF. I'll explain this later to you in the part of CNF examples. Okay, so let's see the third example of this. So this is the third example of DNF, and this we will solve by the method of DNF only. Okay, what can you see this? And first what we did, there is a sign of biconditional in between two variables or two formulas. Okay, and two statements. This is the statement 1 and this is statement 2, and in this the formula and this the sign is of biconditional. Okay, in biconditional I told you that how we can remove this biconditional. Just let me explain you. See this one, see this thing, what it is done. First we did the P and Q and OR sign in between, and then negation P and negation Q. Okay, so there is a sign of disjunction in between, because we need the disjunction DNF form, so we will apply this formula. Okay, so we have done the same thing here. This is the statement 1, this is statement 2, and in these both statements we applied the AND in first part. In second part, what was done in the formula? First we read the statement 1 here and the statement 2 here. Okay, and we have done the conjunction sign, and this we applied both the statements by negation. See, negation as it was given in the formula, that we have to apply both the negation sign. Okay, like this is the variable, but in the question we will be having the statement part. Okay, so deal in that way. So first we broke this biconditional formula into this statement, and we did like this. Hope you understand this thing. First we did statement 1 we wrote here, and statement 2 we wrote here, and we connected by the AND as it is given in the formula, and that how to replace by logical equivalence. Okay, and the second we have to connect by disjunction. Both the statements should be connected by the disjunction sign. Okay, and the next one is like of negation. Between negation for both the statements we have to distribute. We will make conjunction sign in both the statements. Okay, and how we will solve this now? Just think what I have done here. In this, first we will start up with this thing. In this, first I applied the De Morgan's law. In this De Morgan's law, I gave this negation sign to both the variables. I gave to negation P and negation Q. But in De Morgan's law, we know that wherever there is a conjunction sign, we will make it disjunction, and wherever it is disjunction sign, we will make it conjunction. Okay, so we did this part, and this part will be as it is, that because there is no change in this. And we will come to this part now. In this, what we did, that we know that there is a double negation sign. So whenever there is the double negation sign, we can cancel out both this, and we will make it as it is. Okay, and in this same way we applied the De Morgan's law in this part as we applied here. In De Morgan's law, we gave the negation part to P and negation to Q also, and the sign which was in between that of disjunction, we will make it conjunction. Okay, so this was your second step. Now what is in the third step we did? Just see, in the third step we applied the distributive law. Okay, first we remove, in first step we removed the biconditional sign. In second part we applied the De Morgan's law. And third step we applied distributive law. So this is how you will solve the DNF form or CNF form. Okay, in what I have done in distributive law, first I'll give this negation P to P and Q also. So here is negation P with P, negation P with P, negation P with Q, and now I'll give this negation Q to both of these variables, negation Q with P, negation Q with Q. Okay, so this part is solved now, and we will come upon this. So in this we can see that in both the statement there is a sign between is conjunction. Okay, in all the terms there is a sign of conjunction, so we can combine this in one, like P and Q, P and Q, and negation P and negation Q. Okay, so this is the final answer of you. And whenever the question is asked for you have to solve this question by DNF, you will solve by this way. Hope you understand this thing. Okay, now we will shift to CNF part, and we will see the examples of CNF now. Okay, so this is the first example of CNF. In this what we did, P and P conditional Q, and this we just removed the conditional sign and we applied negation or. As we know that whenever there is like this, then we can use P or Q. Okay, this is the basic thing, you should know this. So we applied this and the answer came as we just need conjunction. So we got conjunction now. We got conjunction normal form. Okay, in this we didn't got the conjunction in this way, disjunction, because the question asked for disjunction. So where is the disjunction sign? So for this we go for third step. Okay, so in this the answer is this, and in second example we will see this. We remove this biconditional sign, and in the biconditional sign we use negation P or Q and negation Q. Okay, negation P or Q. Sorry, the question is wrong here. It is like this. Okay, there is not biconditional. Question is like this. So this was your second example of CNF. Now we will see the third example, which is a bit lengthy, but you will, by solving this, you will just have the perfect knowledge for solving the CNF sums. So in this last example, what we did, we just got now that wherever there is a sign of P biconditional Q, what we can do, we can write it as P or P conditional Q and Q conditional P. Okay, so we just have applied this one in the first step. We wrote it as P conditional Q and Q conditional P. Okay, think like this. Okay, this was the first step. And the second step, what we did, we removed the conditional sign in both this thing, and we know that how to remove when we have like this. So we can write it as negation P or Q. Okay, so whenever we have like this, we can write like this. So the same way we have done in this way, conditional is removed by the negation sign, and whenever there is two negation, the negation is cancelled and we will get as it is. Okay, and there is a or sign in between this, as in the same way the conditional part. So we applied the negation sign in P ka part, and negation sign here is what before also. Okay, so this was the second step. First we removed the conditional sign, second we removed first we removed the biconditional sign, second we removed the conditional sign. Now we will apply the distributive law. In the distributive law, first what we did, we just make it like we gave this P to whole of the statement and Q to this whole of the statement. So here we can see the P or is in between this and P or Q whole. Okay, and this and sign will be come in between. Okay, and same as for Q or P or Q. Okay, so this part is done. Now we will say this part, and in this part we applied the De Morgan's law, and in the De Morgan's law we gave this negation to both of these variables, and by giving this negation we have to replace this disconjunction to conjunction. Okay, we know the De Morgan's law now. The same way we did here, we gave this negation to both this and we changed this conjunction to disjunction. Okay, so this was the third step, and in the last fourth step we just applied the distributive law in this part. Okay, this is the as it is part and this is the same as it is. We have not changed in this because this part is solved, because we need the conjunction and we got the conjunction here in between. Okay, and in this we have a disjunction here, so we have to solve this part now. And what we did for that, we applied the distributive law, and that we gave this 2 for this, and second term we did for this. Okay, so we did for negation P or negation P or negation P or negation Q. Sorry, first we did for this and then with this whole part. Okay, so negation P or this whole, then negation Q and this whole again, and we got this conjunction sign in between because we have this conjunction here. Okay, we know that in distributive law the sign which is inside we get it outside, and the sign which is outside we get it inside. Okay, got it. So this was all about the CNF and DNF form. I hope you understood this thing, and have a just nice day. Thank you.